Hello, welcome back. So let's solve one of the problems which appeared in CAT 25. So here we have the function log n square minus 7n plus 11 to the base 14 is greater than 0. So what they are asking here is we need to find the number of distinct integers n for which this equation holds true. Let's see. So let's write the equation. Log n square minus 7n plus 11 to the base 1 by 4 is greater than 0. So typically we have this formula in logarithms where if we have log a to the base b, this can be rewritten as log a to the base x log b to the base x. So we're gonna use this formula and try to derive. So this we have 1 by 4 here, so let's get rid of this 1 by 4. This can be written as log n square minus 7n plus 11 divided by log 1 by 4. Since we have 4 here, let's try to get it to base 2. So using this formula, let's put x equal to 2 here. So this will give us the equation log 2 n square minus 7n plus 11 to the base 2 divided by log 2 to the base 2 power minus 2. So 1 by 4 can be written as 2 power minus 2. Now let's get rid of this minus 2 out. Let's bring this minus 2 outside and simplify this equation. So this will give us minus 1 by 2 log base 2 to n square minus 7n plus 11. Now it is given that this equation should be greater than 0. So that implies, let's multiply both sides by minus 1 by 2, so that will, let's multiply both sides by minus 2. That will give us minus 2, and this will be cancelled. The base 2. Since we are multiplying with a negative number, the inequality changes, so that will be reversed. So instead of greater than 0, now it will become less than 0. So let's simplify, and these minus 2 and 2 will cancel, and minus 1 becomes plus 1. Now the equation becomes log n square minus 7n plus 11 less than 0. We have the base 2 here, so this can be rewritten as we have this formula. So log x to the base b equal to k. That implies x equal to b power k. So using this, we have n square minus 7n plus 11 will be equal to 2 power 0. Upon simplification, this will give me 9 square minus 7n plus 11. 2 power 0 is 1, and we'll bring the 1 this side, so this will become minus 1 is equal to 0, and this will give me n square minus 7n plus 10. So based on the equation, we know the roots are 5 and 2, so this can be simplified as n minus 2 into and minus 5 less than or equal to 0. Now the question asked is we need to identify all the values of n for which this equation satisfies. So let's go to the equation. So let's put say minus 1 here. So this will become minus 1 minus 2 is minus 3, and minus 1 minus 5 becomes minus 6. So this will become positive. So minus into minus, this will become positive, and so it is not true for minus 1. If you put 2, it will become 0. That is also not satisfied. Let's put 3 here. So 3 minus 2 is 1, and 3 minus 5 is minus 2. So this is satisfied for minus 1. Sorry, n equal to 3. If we put n equal to 3, we will get 1 into 3 minus 5 is minus 2. So this is satisfying the equation. Let's put n equal to 4. So that will give us 4 minus 2 is 2, 4 minus 1 is minus 1. Again, this is less than 0, satisfies. And if you put 5, 5 is a root, so it will become 0. And if you put any number more than 5, it will get positive number. 6 minus 2 is 4, 6 minus 5 is 1. So that will give us 4 into 1, and again this is all positive numbers. So this equation does not satisfy. So we have only two solutions which satisfies this equation. So here the answer is option 4.